Right, okay lads, I'm going to go through question 2 in exercise 12G because I had a look at a bit of your work that you sent up, and this is the one that seemed to cause the most problems. I can do more on request, no problem, but I'm going to do this one for now and try and explain how to do it. So you're given a scenario here. This is a scenario 4 from our differential equations that we went through last week. And this is important, and this is what you're saying to me is confusing some of you, right? So this is the conditions. I call them the limits, conditions or limits on the integration, okay? d squared s by dt squared, or dt squared, is 9s. And we know that when ds by dt is minus 6, s is 2, and also when s is e, t is 0, okay? So this is where we had a bit more work to do at the start of the question. I've already written this down now, so you can pause the video if I'm going too fast, right? We let v be the first order differential, so I've got d squared s dt squared here, so we're going to let v is equal to ds by dt. And what we worked out last time was this. Our camera's starting already. Alright. dv by dt is going to be ds squared by dt squared. Okay? Sorry, I'm just pausing because I want this to focus. Right. And we also know by the product rule that dv by ds by dt is dv by dt. Okay, so this is linked to here. Then we can say that dv by ds by v, because ds by dt is v, is equal to this. So we're going to sub this bit here into there, because then we can solve it using integration. We can't solve it this way using integration because it just doesn't work. Okay, so that's the first step. We kind of have to just explain our steps there. Alright, so I've subbed that in. So now we've got v dv ds is equal to 9s. So I bring the ds up, don't I? So we're back into our integration now. So I've got, let's look at the limits now then, right? This is where we go back to v is ds by dt, don't forget. So let's look at the conditions of the start question. That's minus 6 when s equals 2, right? So we put minus 6 and 2 in for our low limits. That's s, that's v. We don't know. We're going to end up with an equation in v and s now, right? When we integrate that, we end up with v squared over 2. Integrate 9s, you end up with 9s squared over 2. Have our limits here. Sub them in. Okay, ignore this side for now. Sub them in. You can pause this as you wish, right? You end up with v squared is equal to 9s squared, right? So this is where it gets a bit problematic with the limits. Because what we do here is we square root this side and we square root this side. But it could be plus or minus this, couldn't it? Because, you know, for example, minus 5 times minus 5 is 25, and 5 times 5 is 25. So when you get the square root, it could be then positive or negative value. So this is really careful here. So we end up with square root of 9 is 3, square root of s squared is s, so plus or minus 3s. Okay. Now we can choose if it's the plus or minus based on, let me get everything in the screen, based on these limits. Okay. So don't forget, v is ds by dt. So that has to be minus 6 when s is equal to 2. Okay? So let's say it's positive. Let's say it's positive 3s. So minus 6, so let's do it here. v is equal to 3s. Minus 6 is equal to 3 times 2 doesn't work, because that's positive 6 is not equal to negative 6. v is equal to minus 3s. Minus 6 equals minus 6. Okay, minus 3 times 2 is minus 6. So that works. So this is the one we choose to go forward with the problem. Alright? Hopefully I explained that clearly for you. When we get to a stage like this, when we get to this stage, it won't always be, by the way, square root. You might have two values there for whatever reason. You choose the one that satisfies the conditions at the start of the question. Alright? Didn't say that last week, so apologies. Has to be v is equal to minus 3s, as v equals 3s does not satisfy the condition. So we're going to substitute now, go back to v is ds by dt. So ds by dt is equal to minus 3s. Go into our integration, bring the s down, dt up. Let's look, now we've got a relationship between s and t. Let's go back to my conditions at the start. S, we know that s is e when t is equal to 0. So, in the limits of integration, put e in for s when t is 0. We don't know, we're going to find that out in a second. Integrate, okay, log of s equals minus 3t, 0t, e and s, limits stay there. We should be okay after this, hopefully, guys. Log of e is just 1, log of s stays there, minus 3t. You add 1, so 1 minus 3t. You put e to the power of log of s is cancelled out to give you s, so it's e to the power of 1 minus 3t is your solution. Okay? Now going by looking at some of your work, this is the key bit, so pause that and go back over it if you're not sure, and we can go through it Wednesday anyway. Okay, next section, I'm going to introduce it, and I'm going to do one example, then I'm going to give you some work to do on Google Classroom, right? So, from your maths course, you should know the following. If I get an expression for s, so say, typically in your maths course, okay, let's say you get an expression for, actually it'd be a negative. They like doing things like golf balls in the maths course, don't they? So it'd be the path of the ball would be parabolic. So let's say minus t squared plus 2t plus 3. Okay. If I differentiate that, ds by dt, it will give me an expression for the velocity. Okay. If I double differentiate it, d squared s by dt squared, it's going to be minus 2. So it's decelerated at minus 2. That probably doesn't work out from the golf ball example because I just made that up. But you should know that from your maths course, right? So if I get an expression for distance, if I differentiate it, it gives me an expression for velocity. Differentiate it again, gives me an expression for acceleration. Okay? And that's how we've notated it here as well, isn't it? Last class. So we're just going to work backward basically for the questions I'm going to give you for Wednesday. However, there's been decision making to be done. Okay, we know that acceleration is the rate of don't forget, differentiation is the rate of change of one thing to the other. So the acceleration is the rate of change of velocity over time. We also know the rate of change of velocity over time by the product rule is dv ds by dt, similar to what we did last week, is equal to dv ds by v, because this is the change of distance with time is velocity. I've just put this, that's the same thing, just put the v in front. Okay, and this is the key thing, right? So here we have two expressions. Number one, hashtag one. Hashtag, see, I'm hipping with it, like hashtagging away like I'm Snapchatting, right? And we decide, this is the decision making, right? And you'll get this with experience. We decide which one to use based on what's given to us in the question. If it's a link between velocity and time, we use this one, obviously. A link between velocity and distance, we use this one, okay? Now I've done an example, well no, there's examples in the textbook, and I've done question 1 there on page 215 if you want to, let's read through it now. Okay, a particle, so we're back to this language that we're used to with moving particles, linear motion, etc. A particle of mass m is projected along a smooth horizontal surface with initial speed 10 meters per second. This is the air resistance to motion of 1/3 mv, where v is the velocity of the particle. No other force acts on the particle. Find the so what we try and do if we get a scenario like this is work out an expression for the acceleration. Okay, we know that F equals ma. We know this is the only force acting on the particle, and it's acting against the direction of movement, right? So That's not this is not a force diagram because I've got 10 meters per second there. Now it's a force diagram, right? So F equals ma minus a third mv because we're working against the motion. So the mass cancels. There we go. That's what we want to aim for as a link. Well, there's an expression for the acceleration. Now, do we use dv by dt or v dv ds? Here. Well, let's go back to the question. Know the first. Find the velocity of the particle after 3 seconds. So here, I want you thinking v and t, okay? Now, of course, if you try one, you just won't be able to put the numbers in or won't be able to work it out. So we're using this one here, right? That's what the decision making is really. Just look at the question. So if I have 1/3 of v is equal to a is dv by t. So we've made the decision now. We're just going to solve it from there, basically. Now, we've got to look at the limits here, or the conditions. Limits or conditions. I used two is for, I don't know why, but same thing. It says a particle is projected with velocity 10 at the start when the time was 0. So we have to try and work that out from the wording of the question. It's not given to us now. We want to find out the velocity when the time is 3 seconds. So that's how I've got 10, 0, 3 and v there. Okay? Starts off with a velocity of 10 when time is 0. We want to find the velocity when time is 3. And then we just sub it in. You should end up with this expression. Okay? There's actually two ways. Actually, I'm just thinking of that when I'm doing this video now. There's two ways we can do this, right? So I've linked in, please camera, I've linked in the two logs here, right? Option 2 should give you the same value. So I've got log of v, take away log 10. I'm going to pause it for a second for this to focus. Sorry, lads. Log of v take away log of 10 is equal to minus 1 basically. So what I did was I used the laws of logs here to do this, right? The other option is you could write it as log of v is equal to log of 10 minus 1. Then you do e to log of v. We have to do the exponential of all this. Log of 10. Right, so you end up with v is equal to e to the log of 10 minus 1. If you type both into your calculator, you get the same value. Maybe not, you might not look the same. If you press change, it'll give you the same value basically. So that's two options there. Okay, so that's example number 1. And example number 2 is question 2 given to you, right? In the book on page 215. So the acceleration is given to you. Sorry, that's what I meant to say there. The acceleration is given to you there, right? So a car, behave camera. A car, you can read this as I'm going through it. It'll focus hopefully. A car starts from rest. So for me now, a car starts from rest. That means velocity is 0 when time is 0, right? Think about the limits there now. When it is at a distance. When it's at a distance s from the starting point, its speed is v and its acceleration is this. So that's our key thing, the acceleration. Show this and find correct. Do that with its speed when s is equal to 0.01. So we want the speed, velocity when the distance is this. So we're going to that's the decision making. We're going to use s dv ds. Okay, v dv ds. Sorry. Okay. So that's our decision making there, not a dv dt. The link is between velocity and distance. So we can put that in there. In this case we can factorize because I've got v here and I got, so it makes things easier for me. So they cancel out. So dv by ds is 25 plus v squared. And then so that was part of the question actually. So to show that part is done. If we bring it down, then this is one of them rules, the inverse tan integration rules, okay? So that's the same as 5 squared plus v squared. Look at the limits here, sorry, the limits I put for integration. So I'll read the question to you. It starts from rest, so the velocity is 0 when the distance is 0, okay? And we want the velocity, that's a v, not a tick. We want the velocity when the distance is 0.01. Okay, that's how we get the limits. It does take a bit of experience. Just think about it as you read through the question. This integrates to that, and then you're away. Basically, I didn't finish that off. Okay, so there you go. There's your tutorial for that little section. I'll put the work up on Google Classroom.